And now I'll introduce our first speaker, Dr. Jaydeep Sharma, an assistant professor in the Department of Botany at the Maharaja Sayajirao University in Baroda. Dr. Sharma will be presenting on the Comps of Gujarat, India, with a talk titled Incongruence Between Phylogeny and Identification in the Asteraceae, a case study of Gujarat composites. Thanks so much, Jaydeep. I'll turn it over to you. You should be co-host now, so you can share your presentation as you like.
Okay, thank you, Colin, for the nice introduction. And again, let me share the screen. Uh, okay, I hope so. Is it visible to everyone? Okay. So, hello to everyone. I'm Sharma Jaydeep, and my talk is a little bit basic rather than in advanced systematics of Asteraceae family. Majorly focusing on the confusion and identification of composites which are found in Gujarat. So let us start with just a minute. Okay, so Gujarat is the westernmost state of Indian country. It is total area around 1,96,000 square kilometer, which is the largest state in India. Gujarat state is divided into the five regions, that is Kutch, Saurashtra, North Gujarat, Central Gujarat, and South Gujarat. Asteraceae is one of the largest family in Gujarat, represented by 12 tribes, 54 genera, and 101 species. So you can see in the map that we are having five regions. So first is Kutch, which is the northern western uh, region, followed by the Saurashtra, North Gujarat, Central Gujarat, and South Gujarat. Uh, and tribe represented in Gujarat is around 12, and you can see that Heliante and Ainule are the tribes which are which are represent a very good amount of taxa, I must say. And intermediate type is represented very less with one genus, that is Artemisia, with two species. Okay, so the study of methodology is sample collection. So 70 species were collected from Gujarat state. Morphological and palynological studies were carried out, and on the basis of that, cladogram was prepared by using two methods, that is UPGMA and maximum parsimony. So let us discuss about some confusing genera. So first of all, it is Oligochaeta and Tricholepis. So both seems to be similar. According to the literature, both are delimited on the basis of the outer florets, which are infertile in case of Oligochaeta, and it is fertile in case of Tricholepis. But during studies, it was found that the both outer and inner florets are fertile, producing gypsellas. In case of Oligochaeta, so it becomes quite difficult to identify on field. So hence another character which can be considered is the branching pattern in the plant. So it is dichotomously or divaricated branches in case of Oligochaeta divaricata, while it is monopodial branching in case of Tricholepis. And yes, further study can also uh, prove that we can consider Oligochaeta to be merged in Tricholepis genus. It can be possible. Earlier, it was the part of Tricholepis genus. Then we are having another two members from Vernonia tribe, that is Centratherum and Phylocephalum. So in both case, the involucre is caliculated, and it is quite difficult again to identify both genus. Again, Centratherum was first included in Phylocephalum, later on it is separated. So yes, only one character can be considered to separate these both is the pappus, which is Codocus in case of Phylocephalum, while it is not in case of Centratherum. Another thing in pappus, we will be able to see two whorls of pappus, while it is single whorl in case of Centratherum. So only pappus remains the one character which can be considered to delimit both genera. Otherwise, it is quite confusing. Next is Eracheron and Essenbeckia. So again, both were previously included in Coniza genus of Asteraceae. Later on, both were differentiated. And again, delimiting characters is not so clear, especially in case of these two genera, because one character only which we can consider is the capitulescence. So in case of Erigeron, it is more or less racemose capitulescence, while it is Corymbos in case of Essenbeckia, but still not a good character to delimit both the genera. Again, there is a further study needed to delimit both of these genera. Coming next, Bidens and Cosmos. So Cosmos were formerly included in Bidens genus, and later on separated. Both have retrosary bark ons. Only the differentiating character is the presence of beak in Chipsella, which is in case of Cosmos, while beak is absent in case of Bidens. Otherwise, it is also again quite difficult on the basis of leaf or on the basis of the peppers. It's not so easy to delimit both the genus. Coming back to Blumia and Nenothamnus, members of Inulate tribe. So first of all, formally both were separated genus. So Nenothamnus is a monotypic genus, Nenothamnus seraceus. But later on the basis of phylogeny, this Nenothamnus was merged into the Blumia, and it was again re-described as Blumia seracea. But again, morphologically, it becomes quite hard to considering Nenothamnus in Blumia, because in case of Blumia, the head is discoid, deciform, where we are having a filiform ray floret, while in case of Nenothamnus, the head is discoid. And here another character which is similar to more or less Mutaceae member is the bilip corolla. So bilipped corolla is again another character which is not found in case of Blumia. Xanthium, another actually we have heard Dr. Bruce Baldwin's lecture, and he has emphasized on Ambrosine tribe. Again, when it comes to Xanthium, it is a very controversial genus. Botany students find very difficult to consider in Asteraceae family because of many characters. First of all, we are having a separate male capitulescence, which is generally not seen in case of any Asteraceae members. Another character in a female we will be able to see is absent of corolla. But major character which draws attention is the condition of stamens. So in case of Asteraceae, it is a general character, a delimiting character is syngenesious anthers, but it is not in case of Xanthium. In Xanthium, you will be able to see a monoidal first condition. And in none of the Asteraceae member, we are able to find a monoidal first condition. And again, fruit is actually an infructescence, which is known as bur. It is not a chipsella. It is a group of chipsella forming a fruit, which is known as bur. So pollen analysis were also carried out using confocal microscopy. So here you will be able to see that using confocal microscopy, a 3D projection of pollen and optical section were able were used to identify the characters of pollen morphology. Excuse me. Okay. So this is how it is seen. So we will be so it becomes quite easy to analyze a 3D structure in the optical section of pollen, adding to again a Eurypelinus family quoted by Edatman that Asteraceae Eurypelinus family, and we are able to see a very variety of pollens in case of Asteraceae family. Another thing that we will be able to see that in case of Xanthium, it is quite different pollen as compared to other Asteraceae members. And again, palynologically also, Xanthium is differing from typical characters of Asteraceae family. And lastly, coming towards the cladistic analysis. So two cladograms were prepared. So this is a cladogram which was prepared of 70 species, and considering Scaevolia tacada, which is member of Gujarat, as the outer group. So on the basis of UPGMA analysis, it was found that the Xanthium is again forming a is beside the Scaevolia, is coming beside to the Scaevolia, and other all are forming another group. And here you will be able to see that in case of Anule tribe members, which is represented by green color, Ericheron and Eschenbachia are sitting inside the Anule tribe, while Cytocline and Thespis are paraphyletic to it. Again, here another character which is quite in another group which is quite interesting is the Cardue members. So here yellow color is denoting the Cardue members, and Cardue members are forming polyphyletic group where Tricholepis and Goniocolon forms one clade and Echinops and Oligochaeta forms another clade. So as I was discussing earlier that Oligochaeta and Tricholepis are quite similar morphologically, but here you will be able to see that Oligochaeta goes with Echinops and Tricholepis goes with Goniocolon. It is it might be due to the pollen structure because Tricholepis and Goniocolon have similar pollen, and Echinops and Oligochaeta also show similar pollens. So might be possible that this group formation is due to the pollen character, but still it is a matter of discussion and a good topic for further research. Coming towards the maximum parsimonious speed, it is again a very elaborated one. So we'll be able to see that the member of Helianthe is showing a polyphyletic. Helianthe alliance shows polyphyly. And here you will be able to see that the Sclerocarpus and Tithona, which are the members of Helianthe tribe, sits inside the Coreopsidae tribe. And Glossocardia, which is the member of Coreopsidae, is forming a group along with Guzontia. Another interesting point, which is there is the Nephele tribe, that is Gamochaeta and Helichrysum clade. It is sitting exactly in middle of Inule tribe. So again, question comes that should it be considered as a different tribe or should it be included in Inule as a sub-tribe? And here you will be able to see that Asteraceae members also, like Erigeron, Eschenbachia, Thespis, Cytocline, it is forming some sort of paraphily along with annulate members, and spheranthus is differing completely from the clade of annulate. Further, you will be able to see that Helianthe tribe is again forming a different clade from Parthenium to Legiskia, and the Eupatoria members are forming completely polyphyly. So Ageratum, Adenostemma, and Chromolina, these all are showing polyphyly nature. And Cazulia axillaris, which is the member of Inulate tribe, is forming clade along with the Cadue members. So it is quite interesting that why it is forming clade. And another thing that sorry, Grangia matras patana, a member of Asteraceae tribe, is also showing polyphyly, and it is sitting between the Senecio tribe members. So many characters, and on the basis of morphology and palynology, many members showing polyphyletic, especially in case of Helianthe alliance. Another thing that while in case of UP geometry, Xanthium stomerium was completely forming a was not included in Helianthe tribe, but in here you will be able to see it is placed along with the Helianthe members. So again, on still there is a very much difference in the characters, but on the basis of morphology also, Xanthium is seated in along with the Helenthe members. So again, question comes that if there is so much of morphological difference and palynological difference in case of Xanthium, how still it is coming along with the members of Helenthe tribe? So here again comes that the controversy between the phylogeny and the morphological character, and also it is very hard to delimit tribes in Heliante alliance on the basis of morphological characters. So this is the new species which was described during my research work. It is the member of Thespis. So earlier there were 3 species of Thespis genus, and this is the 4th which was described. And another interesting thing that all 3 species were herbaceous, and this is the shrubby species. And again, another interesting genera which is further needed to be systematically analyzed in detail. So Thespis is one promising genus. So conclusion, 70 species were collected and characterized from Gujarat. Xanthium shows significant deviation from typical Helianthe traits, suggesting a need for taxonomic reassessment. 27 distinct pollen types were identified from Asteraceae species based on synonyms, symmetry, shapes, aperture type, ornamentation in size. The Helianthe alliance is complex where polyphyly is very common. Nephiliae tribe can be included in Inulae subtype, and status like a status of genera like cytocline and Nenothemus should be restored morphologically. Should be restored because there is as morphological delimitation deviates from the phylogeny. So these are my reference. And first of all, I must acknowledge the International Composite Alliance for providing me a good opportunity for representing my work along with on international platform. Along with that, I must also thankful to Forest Department for and of course, my university, the Maharaja Sayajirao University of Baroda, for providing me necessary permissions and facilities for conducting my research. I am also thankful to my guide, my mentor, Professor P.S. Nagar, and all my friends and colleagues who were with me during my research and on the field studies. Thank you, everyone.
Thank you so much, Jaydeep. It was really lovely to hear about the comps of Gujarat. I really appreciate it. I am thankful that as I look across the names in our meeting today, that we have expertise across a variety of these tribal groups that you discussed. So I'm looking forward to hearing some of the questions and possibly suggestions that these various experts have. Could I just first ask, though, while I have the floor, about this genus Thespis? Which tribe did you say Thespis comes from?
It comes from Asteraceae tribe.
Okay, gotcha. Thank you.
Hmm.
Well, we can open it up to questions now. Uh, so feel free to raise your hand or to just jump in. You can also pass questions through the chat if you like. Questions or suggestions. I'm curious to hear suggestions about the nature of the polyphyly that you're seeing.
Actually, I have choose this topic just to have a discussion with experts in the TICA group. So rather than showing my conclusion, it would be more better to have a discussion with the experts that can guide me and that can also help me to give more insights in Asteraceae family.
Indeed. Well, alternatively, if people are still gathering their thoughts, we can gather up questions and comments and return to talk through all of this together at the end of Erica's talk as well.
Sure.
So if that sounds fine and nobody
Yes,
wants
yes.
to jump in now, then we can transition.
Sure, indeed.
Okay. Thank you, Jaydeep, for that great talk. Um, I'm now happy to introduce our next speaker, Dr. Erika Moore-Pollard, until very recently at the University of Memphis, but now a postdoc in the Department of Ecology and Evolutionary Biology at the University of Connecticut. She'll be presenting on a charismatic member of the Barnadesieae with a talk titled The Missing Link, Bridging Evolutionary Gaps in Asteraceae with a Chromosome-Scale Assembly of Schlechtendalia luzulifolia. Thank you, Erica.
Thank you, Colin. Can everyone see the PowerPoint slide? Perfect. Okay. Yeah, so like Colin said, my name is Erika Moore-Pollard. I am a new postdoc now at the University of Connecticut, though I will be talking about some research that I did through the University of Memphis, where we're generating this draft genome assembly of Schlechtendalia luzulifolia in tribe Barnadesieae. And just to start off, as we all know, Asteraceae is the largest flowering plant family that's composed of over 30,000 species, 1,900 genera, and 50 tribes. If we start to look into genomic representation across these tribes, we can see that some are more represented than others, and that's mainly because of economic importance. So, for example, we see that with lettuce and chicory, chrysanthemums and anthemidae, marigolds and tagedae, and then we also see it with like common sunflower and helianthemum. Within more recent years, we've also been seeing more genomes being produced, maybe that are not as economically important, but are more evolutionarily important as well, such as Carthamus and Carduae, Bidens and Coreopsidae, and then Origeron and Asteraceae. And so with the addition of these genomes, plus additional publicly available genomes, researchers have been able to ask more comparative genomic questions to better understand Asteraceae's evolution. But something you might have also noticed whenever we look at genomic representation across the family is that there is a lot of representation of genomes in the more later diverging lineages, and there's an immense lack of genomes at the base of the family. If we go outside of the family and look at closely related other families within the order Asteraceae or look in Asterids, we also see there's just a lack of genomic resources across the families as well. Especially there's a lack of genomes available in the sister group Cheliceraceae. And this really impacts what types of questions we can actually ask about Asteraceae. And so this is especially relevant to myself and the Mandel lab at the University of Memphis, because one of the main questions that we had been asking is really what genomic factors underpin the diversification and success of Asteraceae. And to really be able to ask that kind of question, you really need to have more genomic resources, not only within the family, but outside of the family as well. And so within the last couple of years, we have been working on a project where we have been trying to increase genomic resources available. So for example, a project that we're working on and hopefully submitting somewhat soon is we generated 3 new genomes, one in Campanulaceae, one in Goodiniaceae, and we've also generated the first Cheliceraceae genome to be able to start asking questions about Asteraceae evolution overall. And so I'm not actually going to talk about this today, and that's mainly because that's not the point of this talk. But I did want to do just a shameless plug. So if you're going to botany, I will be giving a talk about this on that Wednesday. And so if you're at all interested, put that in your calendar and come and see that talk. But another reason I brought this up is because it's just kind of showing how the Mandel lab at the University of Memphis is really trying to increase the amount of genomic resources available to ask questions in Asteraceae. And so that's what led us to start trying to generate this genome, Schlechtendalia luzulifolia, which is in tribe Barnadesieae, which is one of the earliest diverging lineages of Asteraceae. And so one reason we chose this species specifically is because it's a monotypic diploid species. That's especially interesting because Barnadesieae, otherwise, all other Barnadesieae species are polyploids, and so this is the only diploid species. And if you've ever had to assemble a genome, a polyploid genome, you'll understand why we chose diploids. But even so, even if it is a diploid, it came with its own challenges, because recent flow cytometry work actually estimates the genome size to be about 10.8 gigs, which is almost like 3 times the size of the common sunflower genome. So although a diploid, it is still very large, so it comes with its own challenges, which I'll be talking a little bit about today. But it's kind of become a genome of our hearts. We've been working on it for a while, and so we've given it the name the Comp the Ada grass because of the large genome size, but then also because if you can see in the bottom left image, the Schlechtendalia leaves are actually very grass-like, and so there's a bunch of different connections to bring us to that cute name. But yeah, so to generate this genome, we first actually had our collaborator and friend, Mauricio Bonificino. He went and collected Schlechtendalia out in Uruguay, and then he sent us the plants, and we have it growing in greenhouses in the United States. So this, for example, is one of the plants growing in the greenhouse at the University of Georgia. And so using leaf tissue from these plants, we then did HiFi, OmniSeq, RNA-seq, and short-read sequencing. And then from there, we did quality checks on the resulting data, and then we assembled the genome. And so this is a very simplified little pipeline that we did to do this. But one reason today, in doing this genome assembly, we actually resulted in a haplotype resolved and chromosome level assembly of Schlechtendalia. One reason today is a lightning talk instead of an actual talk is because we are still working on this genome, so we don't actually have one completed quite yet. So for example, we've only really been able to scaffold to this point haplotype 1, and we're still working on haplotype 2, and then we're also still working on the breaker annotations. But I just wanted to give this talk just to kind of highlight that there might be a future genomic resource becoming available if you're interested. And so, given that things aren't quite complete yet, I just wanted to highlight a few things about it and then maybe take questions after. So we're going to just talk about a few things about the sequencing and genome assembly methods. So first is the amount of data that it took to actually generate this. We jokingly call this our $20,000 genome because no matter how much data we thought that we got, we're like, this is finally enough. It was never enough, which is why it's taken us about 2 years to finally get to this step. And so, for example, we originally started with just doing 4 hi-fi runs, and then that ended up not being enough. So then we added 4 Revio runs. And so we were able to get like almost 40x coverage, and that's total genome, not haplotype, that's total. Same with OmniSeq. We'll just do 1 OmniSeq, and then we did another, and then we did another. And so now we did 3 different runs of OmniSeq, 2 short read, and then we only did 1 of RNA. And that's mainly just because the RNA is just going to be used for annotation. And so we didn't really need too much for that. But then using all this data, we then assembled the genome. And so these are just some of the genome stats. I'm not going to go through all of them, but I just kind of wanted to provide this information. One thing is that this is the assembly stats pre-scaffolding. So this is just purely like after assembly, but then also doing some polishing with Minimap and Raken. And so we do have still a large number of scaffolds per haplotype, though that was kind of expected considering the amount of data that has gone into it. But we are getting long scaffolds and we're getting a good N50. So we were pretty happy in general with the hi-fi assembly reads. And then for the haplotype 1, we ended up scaffolding it into 8 chromosomes. And so if you're not familiar with these types of maps, this is called a contact map. And this red line, like this diagonal red line, is indicating genomic sequence that is in contact with each other. And so this is essentially saying that there's a continuous sequence going from there, which is what you want with chromosomes. And so given some tools before the scaffolding step, it was able to determine that there would be 8 chromosomes, which is great, and that's exactly what we wanted. And so those chromosomes are numbered in the bottom left corner. And so one thing I do want to point out is that although we are getting these 8 chromosomes, the 8 chromosomes themselves are still pretty small. So again, the genome size is estimated to be around 10.8. And these 8 chromosomes are only about 7.5 gigabases. And so we are missing quite a bit of data. And I think I know why that is. Though, if anyone has some suggestions, like specifically software suggestions on ways that we can try to improve the assembly, given all the data, I would love to hear about it either during the Q&A or afterwards. But we are still at least getting at least a draft assembly that we can use moving forward. The other part of this slide that I wanted to just show is for example, chromosome 1 is 1.5 6 gigabase pairs, which is so large, is very large, and that's larger than some genomes themselves. And so, yeah, that's essentially all I have to show you. So yeah, with that, I'll take any questions.
Thanks so much, Erika. That was wonderful. We can field questions as people have them. You should feel free to raise your hand or simply chime in. You can also post them in the chat, and we'll return to questions or suggestions you might have for Jaydeep as well. I might just start us off, if I may, with what might be a very naive question, Erika, so I hope this isn't the case, but it's interesting how much polyploidy there is in the basal members of Asteraceae in the Barnadesieae. And I'm wondering, is that common across tribes as well, that early diverging members within a tribe show more polyploidy than later diverging ones?
So I don't believe so. I think actually, you know what? I'm not sure. I that's the only tribe I know where almost all of them are polyploids, though I believe someone will probably tell me that there are a lot more. But I myself, I'm not sure. It is a great question though. Yeah, Peter.
Hey, Erica, awesome to see all that work on the genome. I was thinking or wondering, it looked like there was still a lot of sequence in the like shrapnel, the unplaced scaffolds.
Mhm.
And if I was thinking maybe if you try to place some of those manually, that could help. I don't know if you've done any sort of like manual curation.
Yeah, so I haven't done anything manual quite yet. One thing that I've been trying to do is I've been trying to polish with the current reads, to try to make those like longer sequences that can potentially be implemented. Um, yeah, so one thing that's been getting this genome assembly is that I've been trying to polish with so I've been assembling with Hi-Fi ASM and then I've been mapping back the reads to try to help with the length. But with the genome size being so large, we don't actually have the bioinformatic resources to do it fully, and so we have to do it over coverage. And so that's one reason it's been so short. Um, yeah, and so I'm hoping to continue maybe like polishing it some more, maybe trying this like manual at the end. Admittedly, the place that's probably the best is with like Juicebox, which generates that which is what generated that contact map. And I had Jacob over at UGA help me with that because I hate like I'm really bad at Juicebox.
Yeah,
But yeah.
I'm familiar with Juicebox. I've also used the tools developed by Sanger Institute called
Hmm.
Pretext. Um, and they have some great tutorials for that, like manual curation.
And like what step is that at?
So that would be after you do the scaffolding, and then you would realign your OmniC data to the scaffolds,
Okay.
and then you use this tool called pretext map to generate the contact map file.
Okay.
And then you open that in this desktop program called pretext view. And that lets you like move around those unplaced scaffolds and like connect them to the larger chromosomes,
Hmm. Okay.
which I think
Yeah.
that's the same sort of functionality as like Juicebox, Juicer.
Yeah,
Uh,
I it might be good to try that just because like I said I have not been able to get the hang of Juice Box. Like they show videos and it looks so simple and then I try it and I mess it up even worse. So, I'll definitely
yeah,
look into that.
yeah, I know what you mean. Anyways, that's a huge genome, so um, you're doing the Lord's work.
Thank you.
Other questions? Yeah, Jacob.
It's the man himself, the scaffolder.
Hello, do you hear me? Yeah,
Yes.
hi, Erika. I know that I could ask this question via Slack or something, but I decided that fine. But do you know why this genome is so huge? Do you have some like initial like decay around? Because I wonder if it's like 99% just transposable elements or just start.
Yeah, so I'm not exactly sure why it is so large. I'm guessing it's probably old polyploidization events and it just was able to deploy like go through the diploidization process like faster than the others. I will say though as well, Schlechtendalia is also somewhat like the weirdo of Barnadesieae and like in some more recent work it's usually like the taxon outside of Barnadesieae but still like sister to the remaining clade, so it's still usually grouped with it. So it's definitely a unique lineage in the sense that it's just unique, but I'm not exactly sure um I'm expecting there to be a lot of repeats in that, but we don't have the annotations yet to be able to really tell us how much of it is that or anything.
Oh. And like you are missing how much from the flow cytometry estimates in comparison to what has been.
It's like a little over 3 gigs.
But maybe the flow cytometry estimates are not accurate. Maybe it's more.
Yeah.
Can we
Yeah, and
just
that's another thing.
go with,
I know
yeah.
it was a little bit harder, I think, to do the flow cytometry estimates because of just because of the large genome size. Like I'm not sure how well the standards were done in that regard, though I think it is probably supposed to be much larger. So, because yeah, I'm expecting it to be a little bit larger. Like I said, I may be more towards like 10 if we could get it.
Right. Thank you. Thank you.
Thank you.
We have a comment in the chat from OHHID or Pilocella aurantica that says, I'm not sure if it will be useful, but we have measured the genome size of the species using flow cytometry. I don't have the value with me right now, but I can send it to you if you're interested.
Absolutely. Please do.
Oh,
Oh,
thank
hi,
you.
we're yes, please send me that just to see how much it compares with what we had before. Thank you.
Jaydeep, I'll jump in with a quick question. If you don't mind, I'm curious, you described this incongruence between identification and phylogeny. I'm wondering if you are battling against existing floras or if there is not yet a good flora in existence and you're patching together these identifications from other places. I'm just wondering how you imagine this work manifesting. Are you working toward putting together flora for Gujarat?
Actually, when it comes to floristic studies, so it is now have become quite old concept. So people nowadays are not focusing more on floristic studies. Uh, Actually, problem comes when it comes towards the identification on field. So formally classifications were used for identification. Phylogeny shows evolution, but yes, when it comes to delimiting characters, it because while I was writing my thesis, which was completely based on morphology, and I have to use the recent classification, which was given by Funketer, but obvious. It was becoming quite hard for me to preparing key for delimiting on the basis of the phylogenetic tree. Yes, now since there are many problems, for example, if I talk about the cytocline, so cytocline genus was formerly belonging to the Asteraceae tribe, but later on the basis of phylogenetic analysis, it has been shifted to the Inulae tribe. So there are 2-3 papers in which it has been completely shifted to Inulae tribe on the basis of phylogeny. And the problem which I faced was that if we go for delimitation, in case of Asteraceae tribe, the base of anther is some more tailless, while in case of Inulae members, the anthers are tailed. So in case of cytocline, when I wanted to prepare a identification key delimiting the tribes, only the cytocline was the one which I was not able to include it in Inulae because it does not have the tail anthers. So likewise, there were many taxa, I must say, that I think more work can be carried out to which will be helpful for us for delimiting for identification purpose and along with explaining the evolution. I don't know, more new methods can be developed for preparing cladogram, which might be helpful for futuristic studies. Always suggestions are welcome. Many more can suggest if there is anything new which can be carry forward in the research.
Thank you.
Hmm.
Other final questions? Okay, well, thanks so much to both of our speakers, to give them a big Zoom round of applause. Erika, you had an announcement to make before we go.
Yes, thank you for reminding me, Colin. Okay, one moment. So, Jennifer Mandel told me today that to tell people that if you are going to botany, they're going to have a TICA meeting on Tuesday, July 29th from 12 to 1:30 p.m. They are working on a virtual component, so even if you aren't going to botany, you might be able to join. Keep an eye on your emails just in case that does become available. But if you are going, Yannick Woodstra and Isaac Lichter-Mark, both people who have presented for TICA Talks so far this year, will be giving different talks then. And if you have any questions, then you can contact Jennifer Mandel at this email below. And I can put it in the chat really quick so people can copy and paste it. Yeah.
Great. Thank you so much, Erika and Jaydeep as well. That's the end of our program for today. I hope you will both, all of you will feel free to reach out to Erika or Jaydeep if you have questions or suggestions for their work. Until next time.
Thank you.
Thank you, everyone.